Have you said what's up on this? I don't know what to watch.
All right, so the learning objectives, why Python programming is awesome, what I said, and the rest. So starts with why Python programming is awesome. Um, there are many reasons, but some of the very important ones are listed here. The first reason is that it's easy to learn. And I believe that's already obvious from the syntax because in English like syntax, the English we use every day, so it makes it easier to learn. Then it has a large community and resource. The versatility of Python that is can be used for a wide range of applications. You can use Python for almost every and anything. You can use it for AI, you can use it for game, you can use it for data science, you can use it for web development, you can use it for building graphic user interfaces. You can use it for what else? You can use it for basically anything programmable. You can do it in Python. So it has extensive libraries and frameworks. Yes, Python has a lot of libraries and frameworks. One of the most important frameworks of Python is what do you call it? Django, the Flask. You'll be introduced to Flask later on. Um, the, there's Django also. Django is much more how would I say it? Django is for production. Flask is more like for personal projects. Uh, Python is open source, so it means that you are free to use it. Like it's available for free, and you can also contribute to it. So overall, Python is a great programming language for beginners and experts, and because of these many reasons that I just listed. So, what are sets and how do we use sets? So, in Python, a set is a collection of unique and unordered elements. So, the keyword here is unique and unordered. Unique and unordered. So already we know that before we even know that it's unique and unordered, we know that okay, a set is a data structure. For those of us that okay um, are not pure science students, um, I'm sure those of us from science backgrounds will already recognize the word set from our basic mathematics in secondary school. So you know that when you have a set is a collection of elements, items. So, and it must be unique. So, none of those things. So, it's just that they just took that mathematical um, stuff and decided to implement it in programming. So, basically, what set is in maths is the same thing here in programming, but they're just using code to represent it. So, it's a collection of unique and unordered elements. This means that each element in a set is unique and there's no particular order, yes. Then the elements in a set can be of any data type, such as integers, floats, strings, or even other sets. So here's an example of how you create a set in Python. Do my set equals, then you use a curly brace, then inside the curly brace, you supply your elements and separate them with a single comma. So in this example, maybe I should actually dock this so that I can be running the examples on at once. Yes. Okay, so we can see the outputs. It's printing out the whole set. 1, 2, 3, 4, 5. All right. So in this example, we have created the sets. What we did is that we created the sets, like I said, with the curly braces, and then we assigned it to the variable mySets, and then we printed it out.
Sorry.
Oh.
May I say something, please?
Yeah, go ahead. Ask.
Okay. Sorry, is there any way you can make your screen larger? Like the type, the fonts. Could they get any bigger than this, please? Sorry.
I can try. Let me see. Is it the fonts for the notes, right?
Yes, please. It's already looking better.
Okay. Let me try and increase it small.
It's already looking better. Thank you.
That's too much.
Oh, this is nice. This is really nice. Thank you.
Okay. You're welcome. So, sets have several methods that can be used to perform various operations on them, such as adding, removing elements, checking for membership, just like the way lists and tuple and which other ones, any other data structure has. So, and also it has its own methods that are copied from the, I said sets was taken from the mathematical world into the programming world. So some things that you can do with sets with mathematics, you can also do them here, such as your union, your intersection, your difference, and I'm going to be seeing all that. So here are some examples. So we can add elements to a set with the add method. So instead of using that sentence, and 6. We have 1, 2, 3, 4, 5, 6 in the set. As you can see, the particular aspect is too small. Okay. I think it's better now. You can see here that we have added 6 to the set. 1, 2, 3, 4, 5, 6. Okay, so we have the add method. Then we can remove elements from the sets with the remove method. So let's remove elements by sets. And remove. Let's remove. So after removing 2, we have 1, 3, 4, 5, 6 as the resulting set. Then we can check for membership in a set. So when we check for membership is using the in operator. So I can check if 100 is in my sets. So if it's there, it's going to return, it's going to print true. If it's not there, it's going to print false. Boolean value. So it's printing out false here because there's no 100 in my set. Then these are the mathematical sets operation. Like I said, you can do mathematics with sets. Let's create another set. Easier to just copy and so be faster. Union intersection. It's this. Add. My sets. So for the union operation, line 4, we're saying that we want to get the union of my set and set 2. And what the union operation does is that it's going to combine the two sets together into one. So it's going to include all the elements together in one and print it out. So we have it here, 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, the elements are not repeated. So that's a unique ability of sets. We measured it earlier on that it's, where is it? Said in Python, a set is a collection of unique. That's the first thing you need to know about sets. So anytime you want to store something, some piece of data that has to be unique and not repeated, you can use a set. So automatically, it's going to help you to remove the repeated values. So that's that. Then the intersection is on line 5. What we're doing here is that we're trying to get the elements that are both in my set and in set 2. So, and what we have as a result is 4, 5, 6. So in set 2 we have 4, 5, 6, and in set 1 we have 4, 5, and 6. Remember we added 6 here, so yeah. So that's the intersection. Intersection is the elements that are in both sets. Union is the combination of the elements the combination of all the elements is going to print that, and ignoring repeated values. Then the difference, we can do the difference. The difference is going to get the elements that are in my set that are not in set 2. I believe that's it. The elements that are in my set that are not in set 2. So let's look at our results. We have 1, 2, 3. So my sets, we have 1, 2, 3 in my sets. Is it in set 2? No, we don't have 1, 2, 3 in set 2. We have 4, 5 in my set. We have 4, 5 in set 2. So the difference operator is just going to get you, like saying A minus B. So it's going to subtract B from A and give you the remnant as the result. So whatever is left over will be your output.
Switch the placement will make a difference. Like if you took set 2 to over where my set is, you give it a whole different set of figures, right? Like
Yes.
the union and the intersection, no matter for me, you switch them around, it wouldn't make the difference, right?
It will make a difference if you switch for union and intersection. But if you do for difference, it will. Most definitely.
Yeah, I understand.
So earlier on we had 1, 2, 3 as the result. Right now we have 1, 2, 3, 4, 5, 6 as the result. So that is set. It's supposed to be set 2. Correct. Okay, now we're having 87 as a result. So
sorry, where did set from? What was that set was working on before? What was that gave all those figures?
Oh, that is what we use to create a set. I'm calling it that it's an object. So if you want to create a set, either you use your curly brace and supply elements to it, or you use this function, set function. Now, something to take note of is that you can't create, let's say I create an empty set. You can't create an empty set like this because this will give you a dictionary. This is a dictionary, an empty dictionary. This is a set. This is an empty set. Create an empty set. So when I want to create an empty set or you want to create a set with values, you can, this is not just for empty set, you can also supply values to it. Maybe 1, I believe you can also supply values to it. Let's do that. Create set 3. I'm not sure, that's what I'm facing. Print. Okay, set expected at most 1 argument go to. All right. Expecting an iterable. All right, makes sense. So if you are creating a set that is not an empty set with this set method of, let me call it function, it's not a method in this case because it's when you use the dot operator to access it from this maybe a set variable. Then we call it method. Right now it's acting as a function. So when you want to create sets with this set function, if that is going to create an empty set, let's print this out. So I set 3. I just start with set. Okay. So this is an empty set. Then if you want to create a set with values using these same sets, you have to give it an iterable. An iterable, what it means by an iterable is that you have to give it a data structure too. So you can give it a list. I think you can give it a tuple. You can give it, you cannot just supply 1, 2, 4, and it will not understand that. You have to put all the elements inside an iterable, a data structure. So, or let me not say data structure, let me just say should I use the word sequence or collection? Because I feel like a string is also an iterable, but I don't think it's, let me try that. Let me try a string. Let me say hello. Let's see. So you see, a string is an iterable. So it's a data structure. So not necessarily a data structure. So an iterable is something that you can iterate through. It's maybe a for loop or a while loop or any loop at all. So, and to create a set from that iterable. So let me use a tuple. Just have a set with one element, one. And we can use, what else is there to use? Let me see if I can use dictionary. Let me see. Okay. I can use one. So move on. One, two functions. Let's see. So it returns the set of the keys. So, and that's expected. So basically, you now understand how this set function works and how to create it and what a set is. So there are a lot of methods. There are, what we did here was the add, the remove, the union, the intersection difference. There's also the update method, discard method. Yeah. And some of the mathematical methods, such as the union intersection, have their symbol equivalent. So if you don't feel like using the function, the union function, I think union in, is it sound? I mean, writing out. This union again, I think it's plus. Then intersection is plus. I think this is it. Intersection is and difference minus the difference. I have to do something like this. I just got complementary difference or something. Let's see. All right. So let's see if this will print out. So we have it's the same as before. So yes, this is the union operator. So instead of doing using the union function, you can just use this operator. I think this looks easier, simpler, and it's easier on eyes. Unlike when we're just seeing dots, any opening and closing brackets. So this one is just straightforward. My set union set 2. My set intersection set 2. The intersection is 4, 5, 6, correct? My set set 2 difference my set. So that is to say that, okay, I want to print out the elements in set 2 that are not in my set. Then I think here is, I want to print out which outfit is this? 1, 2, 3, 1, 2, 3, 7. So set 2, 7, 9, 8, 1, 2, 3. Okay. Okay, so what this is that I want to print out the complement of the intersection. So what this means is that I want to print out the elements that are in set 2 and in my sets, and exclude the elements that are common between them. So that's basically the complement of this. So this is, sorry, is this yes? That's and. So this is 4, 5, 6. So the complement of 4, 5, 6 is 1, 2, 3, 7, 8. So it's excluding 4, 5, 6. So it's another type of difference. So yeah, you can use the symbols like this. And what else? Sets are useful. Sets are useful when you want to store unique elements. I said this earlier on, and perform sets operations on them, such as finding common elements between two sets or finding the elements that are unique to one set. So before I move on to, okay, let me just go on because, yeah, I wanted to talk about the methods and I have it here. So what are the most common methods of sets and how do we use them? Sets in Python have several built-in methods that can be used to perform various operations. So here are some of the common methods. We've already seen the add method. We can use the add method to add elements to the sets. We have already seen the remove method. We can use the remove method to remove a specific element from the sets. If the element is not found, it raises a key error. So that's something you can also take note of, so that you can, your program will not break. You can do error handling or exception handling. There's also the discard method. This method removes a specific element from the set, but unlike remove, it does not raise an error if the element is not found. So there's a difference between remove and discard. So if you are trying to remove something from the set and it's not there, it's going to raise an error. But if you just want to, if you use the discard, it's not going to raise an error. It's the same thing. Pop. This method removes and returns an arbitrary element from the set. So when it's just like in your lists, when you pop something from your list, it removes the last element in the list and it returns it. So it prints it out. So it doesn't just remove it, it also returns it. So you can print it out. You can save it in the variable you see here, my set.pop. So it's going to remove 3 and it will return it. This pop method returns the value it's removing, and you can save that value in X and print it out. Sorry, it's saying here that output is 1. It seems like it's a different, let's see. Because in lists, the pop method starts from, like, acts from the end of the list. Seems like set is acting from the beginning. Pop method in set is acting from the beginning. But let's, oh, so if you're using the pop method, let me even look at it. It does not have a description for it. If you're using the pop method, it removes the first element of the set. So that's a key difference between the pop in list and the pop in sets. If I should do something like this, do, let me do y. Y is equals to sets. It work. Not if I'm missing out. Int. The average should be 3. So let's see. All right, the average is 3, so it confirms our hypothesis. So pop in sets is different from pop in lists. So we have the clear method. The clear method removes all elements from the set. So we'll call it clear method. Let me call it clear method on my sets. Okay. Let's remove all the elements in that set. All right, so it returns an empty set. So the union, we have seen the union says the combination of the two sets. This method returns a new set that contains all the elements from the original set as well as other sets specified in the The update adds multiple elements to the set. So let's try to update to update. So let's try to update my sets. Now, from what I see, I think the parameter should be an iterable. So in this case, we're going to see 1, 2, 3, and it's not to work just the way this function is going to access this kind of parameter. So it needs iterable. So you can see this is an iterable parameter that is requesting for. So let's type this in an iterable format. I think you can look through it. Like I said, an iterable is anything you can look through with follows. I need to explain it. So we already have 1, 2, 3. So if I do this and I print out the set, I'm not going to notice why. Does anybody know why? I'm not going to notice any updates. Does anybody know why? Hello, can you hear me?
Yeah, I can hear you.
Yes, I can hear you.
No, yes, I can.
Okay, I'm asking,
Yes, because you're
I'm asking a question. I said, if I try to update my sets with this and I print out my sets, I'm not going to notice any updates. And why is that?
Yeah, duplicate
already
values. What is the
Yeah.
so says the whole duplicates.
So 1, 2, 3 is very ready. So the set is just to use the one that it already has. So you see, okay, we removed 1. So it's only 1 that I need to take notice of. But it was there already, so it's not going to repeat itself. Let me use something else. Let me use, let's say, 10, 10. So now we know notice the visible change. 10, 12, 13. Okay, yes, 10, 12, 13. That's because our set was empty initially. Let me remove this clear. I want our set to have something. Next is. So I just have to remove my here. All right, 1, 2, 3, 1, 2, 3. So now if I run, this is 1, 2, 3, and 10, 12, 13. So instead of me using the add, because if you notice, the add method does not, it's kind of slow. You have to be adding one element. That method does not take more than one. And we test that hypothesis. The add method does not take more than one. The update method allows us to supply more than 1, 2, 3, 4. I see. I need something about taking this of the change. Like I see, we have an area feedback called that in file that is in my state. This add type error, it takes exactly one argument and 2 we're giving. So using the method to populate your sets is kind of like slow because you have to be adding things one by one. So thank God for the update method. The update method, you can supply everything inside an iterable and it's going to update your sets. So what's the next method? Intersection, I've seen intersection difference. Symmetric difference, that's the word I was looking for. When we did, I know I said there are 2 types. This is symmetric difference. And this is, what's the other difference? This is just normal difference. So, yeah, that's that. Symmetric difference returns a new set that contains the elements that are in either of the sets, but not in both sets. And like I said, this is the complement of the intersection. These are some of the most common methods of sets in Python. By using these methods, you can manipulate sets and perform set operations. So these are the common ones. If you want to see the full list of methods for sets, right here. No, let me use my commands. Python. There's a command called dir. So dir is going to expose any objects. It's going to expose the method of any object in Python. Basically, everything in Python is an object. Everything. Even if you're number 1, you're 2, you're 3, anything you're writing in Python is an object. So dir is a method that's used to expose the methods of objects. So I want to see all the methods of sets. Okay. I want to see all the methods of sets. So I'll use the dir method, then supply the set words, then click enter. So it's going to show me all the methods that are available for the sets objects. We have the add, we have the clear, we have not seen the copy. I guess that just, so on your own, you can go back and start testing the functionality, how these different methods affect the sets. Difference of updates, discard, intersection update. So there's even an intersection update. Then is disjoint, is subset, is supersets. So it's now these, I guess these are the mathematical operations. Is subset is sets, pop, remove, symmetric difference updates, union, dates, yes. And you can also use len, these are attributes that are generic to the objects, but these are the that are generic to objects itself. But these are the ones that you should take note of. So for now, ignore the ones with the underscore. They are also methods, but for now, just ignore them. They are special methods. So these are the ones you should practice and take note of. All right, so when to use, okay, so let me ask at this junction if there are any questions. Any questions so far?
Yes, I have a question.
Okay, what's your question?
That symmetric difference, does it have an operator? Like, for example, intersection has the ampersand operator.
Yeah.
I don't know. Symmetric difference.
I just showed you the operator. Let me go back. Let me see if my own Zulu history can take me back to. It has an operator. Is the what is it called? Look at it. This is symmetric difference. This is symmetric difference. This is the operator. Is the carat. I believe that's the word. Carat. Let me spell it. The carat symbol I use. So this one is for union. This is for intersection. This is for difference, just normal difference. Right. So I believe this answers your question.
Yeah.
Okay. Any other? If there will be no other questions, then
Okay,
Yes,
I think someone was putting his hands up here.
Yes, I have a question.
I can't see because I'm looking at my editor and I'm looking at my notes, so I can't see the
Okay.
Google Meet. Yeah, so if you have your hands raised, maybe I don't.
Okay, I would indicate for
Yes.
for
Okay.
yeah,
Just
I would
indicate.
indicate for yeah. All right, go ahead.
All right.
Mr. Joshua, you can go ahead and ask your question.
Okay. My question is in that update, my set.update, I discovered that you put the update in a list. You enclose it with a list.
Okay, like I said, the update function takes, maybe I should use let me show you because every method has documentation. So you're going to be doing a lot of documentation. Oh, wow. You are going to be doing a lot of documentation in Python. So brace yourself. So every method for an object has its own documentation. So let's check it. The way you check for documentation is with the help command. So I want to check for let me just create a set. Into x is equals to set. So I want to use help to check for this update. So what is update? What does update do? So I don't know if you can see this. It says help on built-in function updates. Update method of built-in dot set instance. Update is set with unions. Okay, it's not actually showing me what I want. So this is a very, very poor documentation. Very poor documentation. It's not showing me what I want. But ordinarily it should. Let me try it here. My set dot updates. So can you see this? Thank God for IntelliSense in Visual Studio Code. Can you see this stuff highlighted in blue? Hello? Can anybody hear me?
Yes, I can see it.
Okay. So it says that if you are going to be supplying a parameter to this method, it has to be an iterable. So you cannot use direct values, direct comma separated values. You have to use an iterable. And I already defined what an iterable is. I said an iterable is any anything you can loop through. So it can be string, because I don't want to use the word, if I say an iterable is a data structure. A string is not a data structure technically. It's a data structure, but let's not go too deep. Just string is string. It's a data type. Let's just leave it at that. But just understand that an iterable is anything that you can loop through. So anything that you can use a for loop to loop through is an iterable. So you can loop through your string, you can loop through your list, you can loop through your sets, you can loop through your dictionary, you can loop through, basically anything you can loop through. So it's valid parameter. So that's what an iterable is. And I also mentioned that it's not just the update function that behaves like this. There is also it's not just the update method that behaves like this. There is also another one that behaves like this, which is the pop. Is it? No, it's not pop, sorry. What was it? I forgot. There's a method, let me check the list. Add, is it add? No, it's not. Copy, no. Difference, no. Discard, is it discard? No. Intersection, disjoint, remove. I can't find it again, but I shall know it's not just the update method that uses an iterable. There's another one that takes in an iterable. Okay, now I remember. My memory is best. Now I remember. So if you are trying to, let me use my S. I'm trying to create a new set. So if you're trying to create a new set, look at this. Let me write it again so that it brings out. So can you read this? It said set new empty set object. Then, so if you just do sets with an opening and closing parentheses with nothing supplied to it, it's going to create a new empty set object. But instead, if you do set and you supply an iterable to it, then it's going to create a new set object from that iterable. So if I pass in an iterable of string hello, let me do my set update. Let me use my S. Let me do word here. Hello world. So let me move this up. So what I'm doing now is that I'm creating a set, my S, with this iterable hello. Like I said, iterable is anything you can look through. You can look through a string. And I'm also updating that same set with an iterable. So these are the two things that require you to pass in iterables as parameters. So they don't just take anything, any value. So let me show you another before I finally print out the sets. So instead of using string, let's use something else this time. What do you want us to use? Let's use a list. There is a list, and in that list, I can put names. Then I can put, instead of everything in the list being in, because the list can have more than one data type, I can put a number there, I can put a tuple there, 3, 5. I can put, what else can I put inside the list? I can put an empty dictionary inside the list. So print my S. I think I did. It's not my sets, I'm trying to update my S. All right, so what's happening is that create a set, hello, then I'm updating that set with word, and also here I'm updating the set with this list, and inside this list I have J1, then I have a tuple here, then I have a dictionary here. So let's see what would come out. Let me delete every other thing. So that's my output terminal is not crowded. Okay, it says type error on hashable type dict. Let me see if I supply something to it, is it going to work? This can have, let me say, 1, still saying error. So it seems like it's not accepting our dictionary. Let's remove our dictionary from the list. All right, beautiful. So can you see the output? So the output here, first of all, we have hello world. Now, it's the reason why it's scattered like this, because I don't know if you have forgotten. The second thing about sets is that apart from being unique, it's also unordered. So don't expect that it's the way you supplied elements to it, that's how it's going to be in the set. No, because in this case, we actually started with hello world. So some persons might expect that we should have H, E, L, L. Oh no, a set is unordered. So if we want to order it, we can use the sort function. But let me not go there. Let me just explain what I want to explain. So basically, the iterable is this string, and like I said, iterable can be anything you can look through. So in this case, we're using a list that contains different things. So these two things, they take parameters as iterables. And as you can see, we have outputs here. This is our list. Inside this is the name, this is the number. Where's the one? This is the one. Then we have the H, the hello, then we have the word also. WORLD, yeah, is there. And take note that repeated elements are only printed out, are only printed out once. So like in this case, we have Jame. Jame has an E, and hello has an E. And we just have one E in the whole of the set, so it's unique. Word has L, hello has double L, and we just have one L. This is not the same as this. This is the number 1, and this is the letter L. So, yeah. if I want to order this, let me try and order it. If I want to order this, I'll just say sort. Sorted. Okay, sorted. Type error not separated between instances of string and int. Okay. So based on this set is a mixed data type set, we can also see in sense that there's going to be a type error. How do you sort between how do you sort numbers and letters together? I guess sorted functions don't capable of doing that. So basically, if you have a set of same type that can be reasonably sorted, and you want to sort it out, okay, let me remove this. Let me remove this. Let me print out. I make everything string. So everything here is string type, right? So let's sort it. So as you can see, it's sorted now. We have Jane first. Then we have the letter D before E, before H, before L, before O, before R, sorted alphabetically. So yeah. Hope that answers your question.
Yes, sir. Yes, sir. Thank you.
All right. Any other? Okay. Sorry?
Can you hear me?
Yeah, I can hear you.
Okay, I just wanted to ask you, when you printed the first one you printed for the hello world and then the number also, I want to understand the format at which this is printed. Is there another limit for this, or it's still just good and
Let's go back to where's my notes? Let me go back to the notes. Where's the definition for sets? So this is the definition. I said a set is a collection of unique and unordered elements. So whatever you are supplying to your set is not going to be ordered. So I already showed you here that the way you supply elements to your set is not how it's going to appear in the set. So just because you supplied hello first before you updated it with word doesn't mean that hello is going to come first before word in the set. So it's going to be mixed, it's going to be scattered, it's going to be random. So you might see James first, you might see word last, you might see hello second. So it's not ordered at all. Sets are not ordered. Sets are not ordered. Sets are not ordered. Unlike lists, I can say that the way you supply elements to a list is exactly how they're going to be printed out. So I can say a list is ordered because it's exactly how if I supply hello to the list and the next is word, then the next is James. If I print out that list, I'm going to see it exactly that way. Hello, word, James. But if you do that with a set, it's going to scatter it. It's going to mix it together. So it's not going to come out the way you supplied it. So yeah, sets is unique and unordered. And the reason why it's not even ordered is because what's the point of being ordered when at the end of the day, if there is repetition, it's going to ignore. So you might have loss of data. So there's no point ordering it since at the end of the day, it's taking unique values. So majorly, you are going to see the reason for set anyways. the major reason why we use sets in programming. So it's because of these two, um, because of this, not two, it's because of one major thing, the uniqueness of its elements. So we use sets whenever we want to um, um, store unique data. So we don't want data that will repeat. We want to store unique data, or we use sets when we want to check if a particular data is available in our sets. So that is very fast. So just if okay, is there in the set? Use the in operator. So yes, there is no order to sets, and a set is a collection of unique elements. Any other question?
No. Continue.
Right.
I have one more question, but it's not related to the Python language. It's just the your notes. I would like to know how you came up with it like this.
The notes.
If you don't mind.
Okay. The notes is generated by ChatGPT itself. The application I'm using for my notes taking is Obsidian. So yeah, if you are, I would advise each and every one of you to take notes because
What's the application you
I
said?
can't imagine Obsidian. Let me type it out. Obsidian. I can't imagine going through ALX and not taking notes because trust me, 2 months from now you're not going to remember all these things again. It's your notes that will save you. So you have to go back, you have to revisit your notes.
Excuse me.
So there's a
Can you hear me?
lot of things to learn. Yeah, I can hear you.
This Obsidian should be a software that you install
Yes.
and then you make your notes from there.
Yes,
Right?
yes. Obsidian is a software that I use to take my notes. As you can see, I have it structured in this way: foundation, short specialization. So you have the observable, share Linux.
Okay. So this is not even integrated in the VS Code, right?
No. This is a different application. This is a different application on its own.
Okay. Thank you.
You're welcome.
Hello.
So, yeah.
Sorry, please. Concerning the last question that was asked,
Okay.
this Obsidian, you use Markdown language, Markdown scripts, or just typing?
Yeah, you can use markup, you can use normal typing. It's very flexible. I use markup basically.
But I was thinking it was Markdown on VS Code because there's an extension that when you're writing your Markdown, it auto reviews and displays exactly like this. That's what I was thinking.
No, this is not VS Code. This is Obsidian.
Yeah, I think I got that Markdown code. I just got it now, and it displays in this format also. It's just that it does not have a display like this as per functions attached to it. It's just having your notes, and I don't think you can do any edit on it. The edit you'll be using is going to be on the text editor, and whatever you do will replicate on the format, the MD file. That's the only thing it does from what I just tried now.
Yeah. Not only Markdown, I think you can also use markup too. You can write HTML, and I think it will recognize it.
Yeah, work with HTML and the Markdown.
a paragraph. So you see, it recognizes markup too, and is even indicating it that this is an HTML markup language. If I go up, it's going to show me the, if I exit, it's going to display like, so yeah, it's a very nice application. You can use it to take your notes. Any other questions? So if there are no other questions, let's get into when to use sets versus lists. So we are just learning different types of data structures. So how do we know when to? Sorry, Blessing, are you on the call?
Yes, I am. I'm here.
Do I have a time limit for this class?
Yes, we're taking into consideration members who are from other countries, but I think for now we can go on. I don't think this will take too long, right? Am I correct?
It will. I mean, we still have to look at the resources, then go into live coding. And it's almost 11. And I still have a lot to do. So I'll try to speed it up so that we can get to live coding before 11. Can we round up 11? Is that okay?
Yes, that's, I believe it's fine. Guys,
But
okay.
11 is okay.
I think 11 is not bad, so we can go ahead.
So when do we use sets? So like I was saying earlier that we are learning a lot of data structures, your lists, your tuple, your sets, your dictionary. So you, at some point you need to ask yourself, okay, these different data structures, when do I use them? Like, when do I know, okay, maybe I see a problem. How do I know, okay, this is a problem that we need me using a set instead of a list, or this is a problem that we need me using a list instead of a set, so vice versa. So sets and lists are both useful data structures in Python, but they have different characteristics and are suited for different tasks. I just said that. So when do you use sets? You use sets when you need to store a collection of unique elements. I already said this earlier on, that that's like one of the most important things about sets. So can somebody give me an example of a situation whereby you need to store a collection of unique elements?
I think like names of students in a class.
Names of students in a class. Can a set store names of students in a class?
Or maybe registration number of students. Reg number.
Registration.
It has to be unique.
Registration number of, yes.
Students.
Registration number has to be unique. That's true. But
Email
I asked the question. I said, can set store names of students?
Okay, I don't, unless it's no.
Okay, so you're now beginning to see the problem with that, because it's going to, because if you want to store names of students, you're going to store it as a string. And if you try to store that string, it's going to be storing each character in that string individually. And it's going to, because names of students, obviously there will be repetition in some people's names. So it will not store the full name. So it will keep only one and discard the repetitions. So that might cause a problem. So imagine your name is, okay, what name has, okay, my name does not have a repetition. Imagine your name is Mahmoud. Mahmoud. And you want to store your name in a set. Let's try it. Let's try it and see.
Hello, sir.
Yeah, I can hear you.
Yeah, please. I think if we pass the names as a list, each, let's say, for instance, the first name and the last name, if you're passing a list to that string, it's going to hold each element as a different entity. So now, if for instance, now we're passing,
Awesome. Very, very correct. Very correct. I was waiting for somebody to say that because it's actually on my screen here. So I don't know why. Who was the person that I was asking the question? I don't know why you were skeptical. You're not so
Yeah,
sure.
I was not sure, but
Okay, yes. There's a way you can store names of students. In this case, you just have to pass it as a list. You have to pass the names inside the list. If you pass the names as strings, it's going to decompose that strings to characters. But if you pass it as a list, it's going to decompose that list to individual elements, which are strings of yeah. So yes, it's possible, and yeah, that's when you know that you actually do need sets. So when you need a collection of unique elements, so there can only be one Samuel Binijesu in the class. There cannot be two. So if somebody is trying to register as with my name, the set is not going to add it. So it's kind of like a way of saving space too, because instead of having two Samuel Binijesu, so somebody can enter his name twice. So set is a way of like mitigating for that kind of human error. So in case you enter something twice, it's just going to ignore the extra and just to keep the original. So yeah, so you need to perform, okay, when you need to perform set operations like union, intersection, and difference. So that's when you know that you need sets. So maybe you're a data scientist and you're trying to compare two data sets together. So you have data sets for number of deaths in 2022. I have another data set for number of deaths in 2022. I want to compare the number for each month. So maybe you want to do things like union, intersection, difference. So those kind of operations between two different data sets. If you want to perform operations between two different data sets, then set is your go-to data structure. So if you need to quickly check if an element is a member of a set, regardless of its position. So something about list is that for you to check if, although you can, I think you can also do it in list. You can use the in operator in lists. I think you can use the in operator, but the good thing about set is that you don't need to worry yourself about number one, duplicate values. So if you want to check if a member exists, that means you want to check if an element is a member of a set, you can do that quickly without worrying about, oh, is this member duplicate? Is there more than one of these? So you already know that, oh, there's only one of these. So, but you want to check if that is available. You can do that with a set and use the in operator. And it doesn't need you to specify its position or index position. So, and if you don't care about the order of the elements, so that's another thing. If you don't care about the order of the elements, how the elements are ordered, you can also use a set. So, the names of registered students. Let's say you don't really care about who registered first. You just want to You just want to have the names unique. So because there are some people that maybe while using the Google form to fill in their names, they enter the names twice. So some people are, maybe the network was hanging. Let me try it again. Maybe it didn't, let me enter my name again. So in such a scenario, you can use a set. So if the system has already registered the name before, if the person enters his name again, it's not going to add it to the set. Yeah, that's when you use sets. So when do you use lists? You need to, when you use a list, when you need to maintain the order. I already mentioned earlier that set is unordered and list is ordered. The way you supply elements to the list, that's how they come out. You use list when you need to access elements by their position in the list. So when you don't just want to check if the element is there, you want to access the element based on its position. Then you need to use list because sets cannot do that for you. When you want to append elements to a list, so you use list. When you need to access a range of elements from the list, when you need to access a range of elements from the list, use list. So for example, here it says if you need to maintain a record of order in which events occur, or you need to access the third elements of a collection list to be the butchers. In general, sets are more efficient than lists for checking membership and performing set operations, especially for large collections of data. However, lists are more versatile than sets, obviously, since they can maintain the order of elements and support a wide range of operations, such as appending, inserting, and the likes. So ultimately, the choice between using a set or a list depends on the specific need of your program and the characteristics of the data you are working with. So how to iterate into a set? So we're getting to the interesting parts.
So please, can I ask a question, please?
Yeah, go ahead.
I just want to be clear on that. That part of where set does not repeat a let's say one of the elements. So if for example in a set we use at least use the square brackets to store two names that are exactly the same, does it mean that even in that case the set is going to just give out one of them? I think if you are printing out the
yes,
element,
it's going to give out one of them. Let's try it. Let's try it. What do we have here? Let me remove hello words. I need it. Oh shit, I need it. Let me make this. So we have two strings in our sets. We have Jane and we have hello. So let me try and add something else. My s does updates. If I add another list with Jane, so do you see the results?
Yeah.
It's still printed out Jane hello. Although we added, okay, maybe it's because I'm using a separate ad. Let me try from the onset. Let me use the update function. Let me try from the onset. Let me use the same single list. Here's hello. And this hello is small bridge around. Right. So here We have in the list, we have hello repeated like 3 times and James period like twice. So it's not going to repeat like James and hello. So it's not going to, yeah. So that's the power of sets. It's going to make sure that nothing is repeated and everything occurs only once. Yeah. So that's that.
All right, thank you.
You're welcome. So now let's look at how we can iterate through or loop through a set. So we use a for loop for iterating through a set. So let's say we have a set, my set equals to 1, 2, 3, 4, 5. To loop through that set, we just say, okay, for elements in, I believe all of us are familiar with the syntax of for loop. For elements in my set, just print that element. What would that be? We have 1, 2, 3, 4, 5. Beautiful. So this will output 1, 2, 3, 4, 5. Note that sets are unordered, so the order in which the elements are iterated over is not guaranteed. So if you need to iterate over the elements in a specific order, you can convert the set into a sorted. I already spoke about converting the sets to sorted. All right, so that's that about iterating through. But that's not all. There's something we can also do. We can do, I think we can do, just the way we have list comprehension, we can also do set comprehension. Let me try to create another set, my S equals to, so we'll do X or X in range 5. This is going to work. So print my X. We comment this out. So yeah, you can do set comprehension. You can do set comprehension. You can look through some thing and automatically populate your set with it. So yeah, that's another way. So what are dictionaries? Okay, we are done with sets. We are done talking about sets. So let's get to dictionary. Any other questions on sets? If there are no questions, I'm moving on to dictionaries. So in Python, a dictionary is a collection of key value pairs. Key value pairs, take notes. Key value pairs, a collection of key value pairs, where each key is associated with a value. The key acts as a unique identifier for corresponding value and can be of any hashable type, string, integer, or tuple. Dictionaries are useful when we need to store and retrieve values based on a unique key. They are often used to represent structured data such as JSON or XML documents. Here's an example of a dictionary. So already I showed you guys before that create an empty dictionary. Just use an empty curly brace. Don't mistake this for an empty set. That's an empty dictionary. We can have something like this too. Okay. So here we have that we have key value pairs. Key value pairs. Each element in the dictionary is comma separated as usual, but the key value pairs are separated with semicolon. So the element to the right of the to the left of the semicolon is your key, and the element to the right of the semicolon is your value. So Alice is the unique identifier that is pointing to 25. So the way dictionaries work is that if you want to access 25, you can access it with the key Alice. And I'm going to be seeing that. So let me copy this. So I want to access 30. I want to print out 30. So the way I can print out 30 is by using the key that is pointing to 30. So the key of 30 is Bob. So I'll just write here the name of the dictionary, then in square brackets, the key. If this was to be a list, the way I would do it is by indexing, by supplying the index number of 30. Maybe this is at index position 0, this as index position 1. So in a list, maybe I would have supplied 1 as the index, but for dictionary, we don't access value with index. We access values with keys. So here, let's print it and see the results. So we have 30 as the output. So if the key is not present in the dictionary, this will raise a key error exception. You can also use the get method to retrieve a value, which returns none if the key is not present. So, yep, there is a method called get. So just the way we have methods for our sets, your add, your remove, so we have a method called get. Let's try something. The get method. Ages. I want to get the value at, what's the name? Alice. I want to get the value Alice is pointing to. This is not C, but let's just talk like it's C. But that's actually what's happening. Alice is pointing to 25 is a key. So we have it here. 25 is pointed out, so we can use the get method. Then you can add a new key value pair to a dictionary by assigning a value to the key. This is the way you do it. So to save time, I will not. You can also update the value of an existing key by assigning a new value to that key. It's true. The value at Bob is 30. I can update it to maybe 20 by assigning a new value to it. I can add new key value pairs by just having the name of the dictionary and supplying a key that is not already existing inside the dictionary. Because I want to add a new key value pair. So I can add, okay, David, then give it a value of 40, and it's going to be added to our ages dictionary. So you can iterate over keys, values, or key value pairs in a dictionary. So there are more than one ways to iterate over a dictionary in Python. So first of all, you can iterate over a dictionary by iterating over the keys only, or you can iterate over the dictionary by iterating over the values only, or you can iterate over the dictionary by iterating over the key and the value at the same time. And also, you can even iterate over two dictionaries at the same time. I'm going to be seeing that. So for iterating over keys, this is how you do it. You use for key use the dot key method. So quickly, let me just show the methods of the dictionary. Are going to be more than that of a set because dictionary is more versatile. Okay, not exactly more, but still. So we have declared the copy. Where is the key? Okay, here it is. So this is the keys. And if I want to check exactly what keys method do. post a description published shorts. Okay, but basically, what the key, let me use my Okay, so here it's saying that keys is a method, is a set-like object providing a view on the dictionary keys. So basically what it does is that it returns a list of all the keys in that dictionary. So when you do the dots, ages dot key, this is equivalent to saying that I have a list of Alice Charlie. So basically, what this is equivalent to this. So the dot keys method called on the ages dictionary is going to return a list of all the keys in that dictionary. So you can look through that list and print out each individual key. So that's how you look through a list to print out keys only. Then you can do something similar for values, but in this case, instead of using the dot key method, we use the dot value method. First of all, let me print this out so you see it's the same. We have Alice, Bob, and Charlie expected. What are the values? The values, so instead of keys, it's going to return a list of all the values, 25, 30, and 35. You have 25, 30, 35. So for us to iterate over key value pairs, we do it this way. We use the dot item. The dot item method. The dot item method is going to the dot item method is going to provide the items in the dictionary exactly the way they are. So we can use two iterators. You can say key value in this, print out the key and the value, and it's going to print out the key and the value. Alice is 25, Bob is 30, Charlie 35. So you can also check if the key is present with the in operator. So we can check if Bob is present in ages with the in operator. Dictionaries are a powerful data structure in Python that allow you to store, retrieve data based on unique keys. They are widely used in programming language, etc. So when to use dictionary versus list? So dictionary, list, and sets are, like we all said, they are all useful data structures in Python. And they each have their own characteristics and they are suited for different tasks depending on their individual characteristics. So when do we use dictionaries? We use dictionaries when we need to store a collection of key value pair items. For example, I need to store information of the person, such as their name, age, address, the person unique identifier. A dictionary would be a good choice. So a dictionary helps you to quickly look up values based on their keys, yes. You need to update or modify the values associated with the key, yes. You need to maintain the order of the keys, yes. So unlike a set, a dictionary is actually ordered. So we already know when we use lists and sets. So what is a key in a dictionary? I've explained this. It's just a unique identifier that is used to access and retrieve corresponding value. Each key in a dictionary maps to a single value, and the keys must be unique within the dictionary. And also something to take note of is that a key must be a hashable. Another word for hashable is how do I explain? Something you cannot modify. Is something you cannot change. So you cannot modify a string. You cannot modify a tuple. So basically, the condition for keys, for what you use as keys, is that it must be hashable in the sense that it must be non-modifiable. So that's why we use strings. You can use you cannot use lists, because a list, you can modify a list as, you cannot use a list as a key. So it must be something that is non-modifiable. So that's something to take note of. So key in a dictionary can be of any hashable type, which includes most immutable. Okay, immutable is what I was looking for. Immutable types such as string, integers, and tuples. Mutable types such as list cannot be used as keys because their values can change. For example, we have, okay, here we are using strings as keys. Yes. If we try to retrieve a value using a key that's not present, we already know that we get a key error. So how do we iterate over a dictionary?
Wait, yo, sorry, man, I ask something.
Yeah, go ahead.
What does it mean when it says it has a fixed hash value? What does that mean, a fixed hash value, please?
Okay. Let me go back to it.
Just under immutable.
Keys were under immutable.
Yeah, okay. Yeah. That's the paragraph.
Fixed hash value. How do I explain this? There's some, I don't know if anybody here is familiar with hash. So when, obviously you would be, because you have done some tasks that involved you cracking a file. All those crack me files, crack me 1, crack me 2, crack me 4, crack. So if you have done that, you must have come across the fact that each sequence of characters have its own hash, have its own unique hash value. So if I have hello, the hash for hello might be something like this: 0x40x3267. So this is the hash for hello. It is fixed. What do I mean by it is fixed? It is fixed in the sense that a string is an immutable type. You cannot change it. And since you cannot change it, hello is forever going to be hello. You cannot change it. And because hello is forever going to be hello, the hash equivalent of this hello string is forever going to be this value. It's not going to change. So, but however, if you have something like a list changes. So a list changes because we can append values to a list. So because of the changing nature of a list, the hash value is not going to be fixed. It's going to be changing. So I don't know if you get my point.
Yeah, sort of. I think I have to do some study myself. But thank you. Let me not hold you up since it's already night. Thank you.
Yeah. So you can just maybe Google, but this is like more like a low-level understanding of how I understand what's the meaning of fixed hash value, because we have done stuff with hash before, hashing and this thing. So maybe you just need to do a little bit of research. But just know that the keys for the dictionary must be immutable. And if it is mutable, it is not a valid key. It is not a valid key. So that's so how to
Thank you.
iterate over a dictionary? Yeah, you're welcome. How to iterate over a dictionary? We already said it that you can iterate it by using keys. Iterate the keys, values. You can also do something like this for naming age. For naming age, then you get, so if you just use, this is equivalent to this without supplying the dot key. Without supplying the dot key, it's the same thing. So if I just use the ages without supplying the dot key, I'm still going to, it's going to be returning just the list of keys only. So if I just do for naming ages, what this is equivalent to is same as, sorry, your Alice, your Bob, and your Charlie. So if I don't supply the dot keys and I just use ages, it's still the same thing. It's going to return the keys. And with those keys, I can access it and print the value of that is at that key, particular key. In this example, the loop variable name takes on the keys Alice, Bob, Charlie, and the corresponding ages are retrieved using blah, blah, blah. You understand that? This is okay for items. This is iterating about key and value. Okay. I've already seen that. This is iterating over keys only. This is iterating over values. I've seen that. So what is a lambda function? All right. So in Python, there's something called lambda function. Van Rossum, I think that's the inventor of Python, wanted to initially remove this this implementation from Python because what you can do with lambda, you can do it with list compression or set compression. And one of the rules of Python is that there should be only one way to do something. There should be only one obvious way to do something. If you remember your Python hello world tags, I think it's tags 0 or I don't know if it's tags 4 or something. But you have to do import this to print the Zen of Python. So one of the rules in that Zen is that there should be only one obvious way to do something. And the reason why I was wanting to remove lambda was because what lambda can do, list compression can do it, and that's a clear violation of that rule. So if you have something that can do something, so why are we having two ways of doing one thing? There should just be only one way of doing that thing. But he later did not remove it because of the usefulness of lambda with maps. So and we're going to be seeing that. So what is lambda? Lambda is a way of constructing functions in Python with very short syntax. So the way you construct, like, look at this here, say lambda, the way you just construct lambda, then the argument of that function, colon, then the expression of that function. So the typical way that we construct functions in Python is we say the def keyword, we define, which stands for define, then the name of our function, then do semicolon, then we write whatever it is we want to write. But with lambda, we can break this down to just a single line. If I don't have, maybe I have the single parameter, taking in a single parameter. The parameter, the arguments, they are indicated here. If it's more than one, maybe I'm taking in more than one, maybe y. So I'm going to indicate it here. Then your semicolon, this is semicolon. Then whatever it is you are doing in here, maybe I want to return true. Just come here, do return true. Then we need to put return, just put true. And it's going to work exactly the same way. So let's remember, a lambda is a function that is a small anonymous function that can have any number of parameters, but can only have one expression. Okay, it can have any number of parameters, but can only have one expression. All right. It is called anonymous because it is not defined with a name like a regular function. So as you can see, lambda is not in the regular function. We defined it with a name called func name, but for the lambda, we didn't give it a name. Instead, it is defined using the lambda keyword, which allows you to create a function on the fly. So here, arguments is comma separated list of input arguments, and the expression is a single expression that is evaluated and returned by the function. So the result of the lambda function is a function object. The result of the lambda function is a function object, which you can assign to a variable, or use directly as an argument to another function. So what is the return value of? Let me do something. Okay, I think I have something here. I have an example here. So it's important we know what lambda returns. Control V. What I'm going to do is I'm going to be doing what I have here. I'm going to do the same thing with our normal, typical, conventional function. So I'll put this assembly key and return x. So this flag is equivalent to this. So square one, let me call this square one. Func name. What will I say now?
Okay, we have someone with his hands up.
Okay, go ahead, ask your question.
Okay. Please, I want to ask question.
Yeah.
I don't that really been affecting me learning lambda because number
Study
one,
teacher,
how
you can ask your question.
I'm hearing you.
can you hear me?
Yeah, go ahead.
Okay. I said I want to ask a question, and the question is about me learning lambda. How do you check for errors or exceptions when you're using lambda? For instance, now you're declaring a function. Let's say, for instance, what you've just done, and now you want to check for some conditions before returning the square of x. You can do that from a function. But now, how do you check for that particular condition before your lambda runs? Thank you.
Okay. So you can do something like this. If x is not equal to 0. Right? Have this right. If x is not this was not closed. How do I check this? Let me just quickly check the documentation. Should be there. Lambda full-time user now. Let's see. I want to check. I don't think it's possible. From what I'm saying, I don't think because of this.
Sorry. I think, but with list comprehension, you can do that, but it doesn't
With
work
list-
for Lambda. So if somebody
Yeah.
should use Lambda, that means most times we're going to be having exceptions that will break our code. That's why sometimes I don't like using. I prefer list comprehension.
But the thing is, most of the time we're not using Lambda for what list comprehension can do. So I mentioned maps earlier on. So I know what list comprehension can do. Lambda can do it. But that's not what we're going to be using it for, because like I said, there's more than if there is one obvious way to do something, then that should be the way you should use. So although list comprehension and Lambda can do the same thing, but that's not the purpose for Lambda. Lambda is, you see the importance for map, like as you can see here, in this case. So what the map function does is that the map function takes into parameters. It takes in a function as the first parameter, and then it takes in an iterable as the second parameter. And what it does is that it applies the iterable to the function, and then returns whatever the result is. And then you can output the result. You can convert the result to a list then before you output it. So this is why we need, because to do this using a normal function, a normal conventional defined font name, it's going to be ugly. It's not like you cannot do it, you can do it, but imagine coming here and doing def, then font name, then you now do semicolon, then you now indent, come down and indent, then you now do return. Basically, you have to define your full def, font name, everything inside this place. Or you can just do something like this. You can save the name of that function to a variable, but still it's not as efficient as using Lambda. So basically, this is like the most important reason why Lambda is used, because of the map function, and not because of list comprehension. Although you can do list comprehension, but that's the most important reason is because of this map function, and we're going to see that shortly. So hope I've answered your question.
Yes.
Okay. So as you can see, look at what they wrote here. It says lambda functions are often used as short throwaway functions that you define inline, where you don't want to go into the trouble of defining a separate function using the def keyword. They are also useful when you need to pass a function as an argument to another function, such as the map, filter, and the reduce function. So here's an example of the lambda function that spells its attributes. Okay. We already have it here. Exactly. In this example, the lambda function takes a single argument x, this single argument, and returns the square of that argument. Now, I don't know if an if condition can work here, because the issue with this is that whatever you are going to be doing here should be a single statement. That is the condition for our lambda function. Let me go back to the definition in case I'm forgetting. Say a lambda function is a small anonymous function that can have any number of parameters. So our parameters can be as many as we want: x, y, z, a, b, d, up to any number of parameters we want. But it said, but it can only have one expression. I'm looking at our template. This is the template for creating a lambda function. We can have as many arguments as we want, but only one expression. So if there exists a way of combining each statement and your x raised to power 2 together to form a single statement, then yes, it's possible. For now, I don't know why. I don't know why I can't do it. I don't know if it's possible. But just keep on trying. If there is a way you can combine into one statement, but the thing is that it must be one statement. It cannot be more than one statement. If it's more than one statement, then it's not going to work. Already, what I was trying to do is it's already more than one statement. I do if x is not equal to 0. I need a way of terminating this by if block. So how do I do that? I don't know yet. So I don't think it's possible, but you can try, Sha, but it has to be a single expression. Then lambda functions can also take multiple. Okay, already said that. And another reason is because the expression that you are using here is going to be returned automatically. So I can't. So what's happening here is that there's an invisible return here. It's implied. You don't need to write the return by yourself. It's implied. So that's why whatever your expression is, it must be a single expression. Because you can't start doing condition in your return statement. If you are doing, I can't do something like this here. If x is, I can't start doing something like this here. X is not equal to 0, then now no, it's not going to work. See, it's already showing you red and defensive. So there's an implicit return here. It's invisible, it's implied. You don't need to specify it. Expression. You don't need to specify it. So it returns automatically whatever expression you supply here. And in Python, the return statement can only return one expression. You can return more than one value, but you can't return more than one expression. So you can actually do something like this. You can return something like this. You can return x to the power 3. To work, you can return more than one value. But when you want to now start adding if into this place, things like if or for, you know, you can't do 4 inside your return statement. So that's why it will almost be nearly impossible to do an if condition in this place because there is an invisible return in front of this expression. So that's your lambda. That's lambda for you. What are map reduce? What are the map reduce and filter function? Okay, so now that we've introduced the lambda function, let's look at map reduce and filter. So map takes a function and applies it to each element of an iterable and return a new iterable of the same length with the transformed elements. The general syntax of the map is this. You have a map function that takes in the function argument and an iterable argument. And it applies this function to each element of this iterable. So it applies the function to each element of this iterable. So here, function is the function applied to each element, blah, 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 blah. So you can use map like this. So let's see. Let's copy this. So this is a list of numbers. And already we know it's an iterable because, like I said, an iterable is anything you can loop through with a loop. And so here we have an anonymous function. We created an anonymous function using lambda. The reason why it's called anonymous is because it does not have a name. So anything that does not have a name is anonymous. We created an anonymous function here using lambda. And what it does is that it squares x. It returns the square of x. So this map function, like the definition says, is going to apply this function to each element of this iterable and return a list of the results, a new list of the results. So let's print out what will be squares at the end of the day. Squares. So we have a map object. So before Python 3, if you try to print squares, it's going to print the list of, the modified list. So that means it's going to print 1, 4, 9, it's going to be 1, 4, 9, 16, 25. So if you print square, it's going to be 1, 4, 9, 16, 25. But as of Python 3, they changed it that, okay, the map function should return a map object. So the way we can get the value is by passing this map object to a list function. So I converted that map object to a list. Now we should get the values. So now we have 1, 4, 9, 16, 25. So this is the major reason why we need to know lambda. This is the major reason why we need to learn lambda, because of the map function. I can't imagine doing def function name and return statement inside this place. It's going to make our code look ugly. So it's very concise and straight to the point. We have an anonymous function that is squaring each value in our numbers iterable, and we can print a list of the results of that. So now let's talk about the reduce. Now we know about map. Let's talk about the reduce. The reduce takes a function and applies it cumulatively to the elements of an iterable, returning a single value. The general syntax of the reduce is, we have this. So it's the same syntax as the map. Function iterable, function iterable. So here, function is the function to apply cumulatively, and iterable is the iterable to reduce. For example, to complete the product of a list of numbers, you can use reduce like this. So we have a list of numbers here, and copy this. So the reduce function is not, how do I call it? It's not a Python, it's not an inbuilt Python listing. So you have to import it. It has its own library. So you have to import it. You have to say, okay, from fun to import reduce, or you should be able to use it. Then here we have a list, and what we are doing is that we are passing a function, an anonymous function, to the reduce and an iterable, our list, number list. And what our anonymous function is doing is that is returning the product of two numbers, x and y. So if we apply this to, let's print the products and see what we get. So you have 120. So what's happening here? What's happening here is that it's going to take the first two elements of our iterable. So 1 and 2. 1 is going to be substituted in x. 2 is going to be substituted in y. It's going to multiply it. It's going to multiply it 1 times 2, that is 2, and keep it. Then it's going to go to the next. 2 times 3. Then it's going to go to the next using the former results as our new x, then the next value as our new y. 2 times 3, that's 6. 6 times 4, that's 24. 24 times 5. 24 times 5, that should be 120. Yes. So that's exactly what's happening here. So the reduce function typically does almost the same thing as the map. So what's then the difference? Let's check. Here the lambda function reduce. Okay, I haven't mentioned. So let's look at the filter function next. The filter function takes a function and applies it to each element of, I think the only difference in this case between the reduce, and the map function is that the reduce does not return an object. So it returns a single value. But for our map, remember that our map returns the object. And we have to convert it to a list before we can see the output. So here we did not convert it to a list. We just used reduce and it returned the value that we needed directly. And we are able to print it out directly. So the filter takes a function and applies it to each element of an iterable, returning a new iterable with only the elements for which the function returns true. The general syntax for filter is the same syntax as reduce and map. So let's look at an example. Let's use this. So what I have here is 1, 2, 3, 4, 5. So these are the iterable number. So these are our anonymous function, lambda. Let's look at the definition. It says it takes a function and applies it to each element of an iterable, returning a new iterable with only the elements for which the function returns true. So the function that we have here, so this is how we do our condition. That guy that asked how we check for conditions, this is how we check for conditions. So I knew it was possible, so I was just trying to get the syntax. So you don't actually have to indicate an if statement. Just use x modulus 2 equals 1. So this is a single statement, and we can return something like this actually with a normal return something like this with a normal defined function name. So this is a single statement. So this, whenever you want to do condition checking with lambda, this is how you do it. So here we are checking to see if the number x is an odd number or the remainder is 1. Yeah. When you divide by 2 and the remainder is 1, it's odd. So we're checking to see if the x is odd. So we're going to be applying this to each number. Let's print. What is it returning? Let's see the value that is returning. Or it's going to return a list of
Hi guys, I thought it was my own network. I didn't know it was from his end because my network has been acting funny. And
Okay.
yeah, okay, he just left the meet, so I guess it's network problems. All right, our time is actually fast spent, so this was wholesome. In fact, I don't know. We need to rob that guy. That his notes is he has everything, so we need to rob him. Who agrees? Who is going to join me in this plan?
I'm going to drive the getaway vehicle.
Okay, well done, guys. Thank you so much for staying up to this time. It was an amazing session, and let me not talk too much. It's time for us to unmute and say good night to each other. I'd look for to end me. Can you hear me?
I can hear you now. Lost you for a minute though.
Oh, okay. I said I would look for a way to reach out to him and let him know that we had to end the meet. Okay, because our time is fast spent, and yeah.
So are we saying a good night?
Join. Thanks, already out.